In this video, we're going to discuss kinetic and potential energy and how we can use equations to calculate that. Yes, this does mean we're going to be doing math in science class, so buckle up. You will always have a calculator and you will always have the equations provided to you, but you need to know how to use these equations to solve for kinetic and potential energy. So let's get you these equations. Kinetic energy, remember we said, was the energy of motion. This is the equation for kinetic energy right here. Ke equals 1/2 mv squared. Please make sure you write this down on your notes. This is very important. Remember that this tiny little 2 here, right here, this means squared. So when we're typing this into our calculator, we're going to actually type in 1/2 or 0.5 times the mass times the velocity times the velocity. You need to know what each of these symbols stand for. You need to know that kinetic energy is symbolized by Ke and that joules is the unit of kinetic energy. Please make sure you're writing these down with your equations. You need to know that mass has the letter m, and the units for mass is kilograms. And you need to know that velocity has the unit of a v, and that velocity has the units of meters per second. So anytime you say a joule, you're going to know it's energy. Anytime you see a kilograms, you're going to know it's mass. And anytime you see a meter per second, you're going to know its velocity. We also need to know what the equation for kinetic energy solved for math. Remember, in algebra, you've talked about how to solve equations for different variables. Remember that our kinetic energy is 1/2 mv squared. If I now want to solve this for the variable of m, I can do some nice rearrangement here, and I can take this 1/2 and multiply both sides times 2 to get 2Ke equals mv squared. Now to solve for m, I'm going to divide both sides by v squared. And I end up with the equation m equals 2Ke divided by v squared. This is the kinetic energy equation solved for mass. Please write this down in the second box in your notes. Make sure you have this somewhere. Every time we solve an equation or solve a word problem in science, we're going to use these steps for solving. First, we're going to identify what the question is asking. Second, we're going to identify the variables. Third, we're going to write the equation. Fourth, we're going to insert those variables into the equation. 5, we're going to solve. And 6, we're going to double check our work, making sure we include units. All right, you ready? It's time to practice. We have the equation, or the problem. What is the kinetic energy of a 45 kilogram object moving at 13 meters per second? So let's flip to a whiteboard here where I have this equation written out for me. Step 1 is to identify what the question is asking. I'm going to look for the word what, and I'm going to see what follows it. This equation is asking me to identify the kinetic energy. So every single time, I'm going to start by identifying my variables and identifying what the question is asking. I'm trying to find kinetic energy. So right now, this is a question mark for me. What are the other variables of our kinetic energy equation? We have mass, and we have velocity. So I'm going to see what numbers means mass and what numbers mean velocity. I look for the units of kilograms for mass And I see that I have here a 45 kilogram object. So I know that my mass is 45 kilograms. My velocity has a unit of meters per second. So I know that my velocity is 13 meters per second. So step number 2 down, I've identified my variables and I've figured out what the question is asking me. Next, I am going to write my equation. Kinetic energy equals 1/2 times my mass times my velocity squared. So time to insert my variables. Right now I don't know what kinetic energy is, so I'm going to leave kinetic energy as letters. I know that my 1/2 is going to remain the same, but remember, I'm trying to type this into a calculator. I'm not going to type in 1 divided by 2. I'm going to type in 0.5. My mass identified as 45 kilograms. And my velocity identified as 13 meters per second. And I have that tiny little 2, remember, and that means squared. So I'm going to do times 13 twice. This squared here means that I do it 2 times. So I'm going to take all these numbers and type it into my calculator, and I will find out that kinetic energy equals, in this problem, 3,802.5. But I am not done. I need to include units. Remember that my units for energy is joules, a capital J. I'm going to ask you when we're doing these problems like these to please circle or box or some way let me know what that right answer is. Let's try another one. Determine the kinetic energy of a 500 kilogram roller coaster train which moves at a speed of 20 meters per second. Step 1 is to identify what the question is asking. It's telling me determine. Determine is just like seeing the word what, and it's telling me to determine the kinetic energy. So I am trying to find kinetic energy. That is my unknown. That is what I'm solving for. Next, I need to identify my variables. In my kinetic energy equation, I have mass, and mass's units is kilograms. So I see here that I have 500 kilograms. And my other variable in the kinetic energy equation is speed or velocity. And my units for velocity is meters per second. So I'm going to look for the number that has m/s, next to it. And I'm going to see that that is a 20. And my velocity is 20 meters per second in this equation. Step number 3 says write the equation. I know that KE equals 1/2 mv squared. So now I'm going to start entering what I know. I'm trying to find KE, so that still remains the letters. But I know that my 1/2 to type it into the calculator, I'm going to put 0.5 into the calculator. My mass is 500. And my velocity is 20. And remember that because there's that little squared there, I need to multiply times 20 twice. So I'm going to enter these numbers directly into my calculator. And when I enter these numbers, I found out that my kinetic energy equals 100,000 Step 6 in my steps for solving a word problem says to double check that I did my work correctly and to double check my units. And I notice here I didn't write any units, so I need to add units here. My units for energy is joules. If you don't remember to tell me units, I cannot give you full credit on the problem. So make sure every single time that you have units in there. All right, our final kinetic energy practice problem here. A man with a kinetic energy of 440 joules runs at a speed of 4 meters per second. What is the mass of the man? My first step in solving word problems is to identify what is the question asking. I look at my question and it says, what is the mass of a man? So I know that I am trying to find my mass. That is my question mark right now. Next, I need to identify the variables I know. I know kinetic energy. Once you figure out what you're asking, you should find all the other variables in your problem. Kinetic energy has the units of joules, so I'm going to look for that capital J, and I see that my kinetic energy is 440 joules. And our last variable in our kinetic energy equation is velocity, and velocity has the units of meters per second. So I'm going to look for where I see m/s, and I'm going to see that my velocity is 4 meters per second. Step number 3 says write the equation. Ke equals 1/2 mv squared. But wait, I'm not solving for Ke, I'm solving for mass. So remember how I had you write down that equation, solved for m? I'm going to use that one this time. M equals 2 times the kinetic energy divided by velocity squared. And so now I can enter my numbers for my variables. I'm trying to find mass. I have a 2. All of this is going to be divided. 2 times my kinetic energy, 440, divided by my velocity squared. And remember, because it's squared, I need it in there twice. So 4 times 4. And I'm going to enter all of these into my calculator, and I'm going to find out that my mass is 555. But I'm not done. I need units. Remember that my units for mass is kilograms. That's the very important step at the end to make sure I have units in there. So this is how we calculate kinetic energy. So hopefully at this point you have a couple examples written down. You feel pretty comfortable with this, but do not worry. We are going to calculate many more of these. We're going to do a lot more problems. Moving on to potential energy. There are 2 types of potential energy. Gravitational potential energy, which that's the energy stored in an object because of its height. So this car right now has gravitational energy because it's up on a hill. And you have elastic potential energy, the energy stored in an object because it's stretched or compressed. So if you pull a spring, that stretches it. If you push down on it, it's compressed. It means it has potential energy right now because that spring is going to snap back into place. We're going to talk about gravitational potential energy, where we're going to calculate here. The potential energy equation is that potential energy equals mass times gravity times height. Our symbol PE stands for potential energy, and all energy units is joules. Mass is in kilograms. Gravity, this is the acceleration due to gravity. You just need to know that this will always be 9.8 meters per second. This is really, really important, and please write this down, that G always equals 9.8 meters per second squared. And our height is in meters. Some of you have seen a triangle like this before, some of you haven't. This is a triangle to help you solve the problems and help you work around an equation. So say I'm trying to solve for potential energy. What you do to use the triangle is cover up what you are solving for. So say I was solving for potential energy. I'm going to cover it up. And I'm going to work right across that. Potential energy equals mass times 9.8 times height. That's the equation we had before. Let's try something different here. Instead of solving for potential energy, let's solve for mass. So I cover this up, and I see that mass equals potential energy on top divided by G times H. And we see that potential energy divided by gravity times height is our mass. And say we wanted to solve for height. I would cover up height, and I would see that height equals my potential energy on top of my mass times gravity. And this is how you use the triangle to help you solve these problems. Let's practice some of these problems. All right. A 50-kilogram object is located 5 meters above the ground level. Find its potential energy. Step 1 in solving problems is to first identify what you are trying to solve for. So this says find potential energy. So potential energy is my unknown, what I am trying to solve for. Step 2 says identify variables. In my potential energy equation, I have 3 variables. I have m, and mass, remember, has a unit of kilograms. So I'm going to look for kg in my equation, and I'm going to see that I have 50 kilograms. My other unit here is going to be g, which is always the same at 9.8 meters per second squared. And my last unit, which I should be able to find in my equation, is h, and that is height, and height has a unit of m for meters, so I'm going to look for that m, and I'm going to see that I have 5 meters. Step number 3 says write out the equation. PE equals mgh. Step 4 says insert known values. So I am trying to find potential energy. That's going to remain exactly how it is. My mass is 50. G is what it always is, a nice 9.8. And our height, h, has a height of 5 meters. I'm going to take these numbers and I'm going to plug it directly into my calculator, and I'm going to find out that my potential energy equals 2,450. Am I done? No, of course not. I don't have any units here. Remember that a unit for energy is the capital J, which stands for joules. Let's try another one. A 12-kilogram cat who is resting on a tree has a potential energy of 50 joules. Calculate its position or height. Remember that my first thing to do is to identify what I'm trying to solve for, and I look for this word like calculate. And it says calculate its position or height. So I know that I'm trying to find height. Now I'm going to go through and I'm going to identify variables that I do know. I'm going to start with the energy one, potential energy. Potential energy has the units of a J, so I'm going to look for the J in my problem. And I'm going to see that it has 50 joules. Next, I am going to look at G, which is always the same, which is 9.8 meters per second squared. And my last thing is my mass. Mass has units of kilograms, so I'm going to look for the kg in my problem, and I see that I have 12 kilograms. Step number 3 says write the equation. I'm going to again draw the triangle for you. You can reference your triangle. And we know that potential energy equals M times G times H. I'm trying to solve for H, so I'm going to cover up H. And I'm going to see that potential energy divided by mass times gravity, because PE is on top of the M and G, equals my height. So I'm trying to find my height. Now that I have my equation, I'm going to just simply plug in my numbers. And so for potential energy, I'm going to plug in 50. For my mass, I'm going to plug in 12. And for G, I'm going to plug in, as always, 9.8. And I'm going to enter these directly into my calculator. And I'm going to find out that my height is 0.425 meters high. One more practice problem. A girl runs up a 5-meter high flight of stairs, and she has 1,000 joules of potential energy at the top. Calculate her mass. First thing to do is identify what the problem is asking me to solve for. And I'm going to look for that keyword of calculate. And I see that it says calculate her mass. That means that mass is my unknown. Now I need to identify what I do know. I'm going to start with potential energy because I know this is a potential energy problem. Potential energy has the units of a J, or joules. So I'm going to look for that J, and I'm going to see that my potential energy is 1,000 joules. Next, I'm going to look for my next unit, or my next variable, which is height. Height has a unit of M, so I see that I have 5 meters of a height. And my last variable in potential energy is G. It will always be 9.8 meters per second squared, even though G is never found in the actual problem itself. Next, it says to write the equation. Again, we have one of those situations where I need to draw my triangle because I have something other than potential energy I'm solving for. I'm going to cover up my mass, which I'm solving for, and I see that mass equals the potential energy divided by G times H. I'm going to put in my variables that I do know. I know that my potential energy is 1,000. I know that my G is always 9.8. And I know that my H is 5. Remember, I'm doing all of this to solve for my unknown, which is mass. When I type this into my calculator, 1,000 divided by 9.8 times 5, I find out that my mass is 20.4. But I am not done because I need to include units. My units of mass are kilograms. Alright, at this point, this concludes our practice of kinetic and potential energy. Please be sure to check out the other 2 videos showing me demonstrate more practice problems as we continue to expand our abilities to solve kinetic and potential energy problems.